Welcome to Electrolytes. Now, I am recording this at like 5 o'clock in the morning, so if you don't quite have my same energy level, you'll know why. Aqueous solutions, by definition, contain both a solute and a solvent. And aqueous means we dissolve it in water, the universal solvent. When we mix a solute and a solvent together, we end up with a solution. And the AQ describes the fact that we have a solution, a homogeneous mixture. I threw this slide up here because I thought it was pretty cool, especially for those of you involved in the medical sciences. These are the main electrolytes we find in body fluids. They easily dissolve in water, our main component, and each one of these electrolytes is essential for human functioning. A strong electrolyte, by definition, dissolves 100% in water, and it can cause a light bulb to light up. Now, the concentration affects how much the light bulb will light up. So if you have a real high concentration, it lights up a whole big bright light. But if the concentration is dilute, the light bulb won't light up very much. But a strong electrolyte, by definition, dissolves 100% in the water, or as close to 100 as we can get. But what that means is if you take something like hydrochloric acid and put it in water, you end up with nearly 100% hydrogen ions and 100% chlorine ions. Take sodium hydroxide. It is a strong electrolyte. And when you take that solid sodium hydroxide and you put it in water, you end up with nearly 100% sodium ions and 100% hydroxide ions. Yes, this is the chapter with the solubility rules. Here's a neat way to help you remember the solubility rules. Nitrates, acetates, and group 1 are always soluble, so NAG. Sulfates, ammonium, and group 17 are always soluble, SAG. Our exceptions are PMS, when they're hooked with lead, mercury, or silver. Make sure you know the 6 strong acids. These have to be known. Essential chemistry grammar. So HCl, HBr, and HI, those are 6 of the strong acids. Hydrochloric acid, hydrobromic, and hydroiodic. And then don't forget nitric acid, sulfuric acid, and perchloric acid. There's also 6 strong bases. 3 of the alkaline metal hydroxides, lithium, sodium, potassium, and then with your alkali earth metals, you've got calcium, strontium, and barium. These are all strong electrolytes. They'll dissolve 100% in water. Weak electrolytes, on the other hand, don't dissolve 100% in water. Take acetate, or rather acetic acid. When you put that in water, you see that double arrow thing? Well, that double arrow thing means that, yeah, look, some of these ions are going to, where's my pencil? There we go. Some of the ions don't separate, and some of them do. These are considered to be weak electrolytes. Would it be possible to take a weak electrolyte and get a really bright light bulb? I'm going to leave that for an extra credit answer in class. Weak electrolytes, if we had the exact same concentration as, say, a strong electrolyte, the weak electrolyte isn't going to light the light bulb up as much as a strong electrolyte. Could I get that light bulb brighter? Tell me how. This is just another picture like the previous slide showing that some of the acetate molecules stay together with hydrogen and some of them don't. Now, a non-electrolyte, that thing does not fall apart at all in the water. It does dissolve, note the AQ, but the molecule stays together in water. Sugar's classic example of a non-electrolyte. Up next, molarity.